Thank you for joining today's webinar. You are in the lobby. The webinar will be starting soon. Thank you for joining today's webinar. You are in the lobby. The webinar will be starting soon. Good evening and a very warm welcome to tonight's webinar, which is being hosted by IET Buckinghamshire Local Network. My name is Andrew Dodd. I'm one of the members of the Local Network Committee, and shortly we'll be joining Keegan Neve for tonight's talk, which is entitled The Road to Pi Wars. Just before we ask Keegan to start his presentation, I'd like to just tell you about one or two things. The IT is currently undertaking a survey to understand better the characteristics of the IET community's audience and how well they are being represented by their local networks. In order to understand that better, with a lack of a lack of information, there is a survey being held. I will put up the URL to it and on the chat line, and if you wish to take part, we'd be delighted to receive your comments. So that's a survey the IET is running. We will be issuing a CPD certificate for this evening. CPD certificates are easily downloadable from the IET website, but I have put a very specific one for tonight, and it will be going on the IET Bucks website. If you ask for the IET Bucks homepage, or alternatively Google IET events, IET Bucks events, that will take you straight through to the page. And you'll then see, if you look under blogs, you'll see it posted there. That will be going up in about an hour's time. Tonight's session is also being recorded, so that if you miss part of the presentation or wish to go back over it, the recording will be posted again on the IET Bucks homepage. It will probably take about a week or so before it goes there. If anybody has any problems accessing it, please drop me an email. My email address is on the details of the events and is also on the IET Bucks webpage. Looking forward to the future, coming up in May, on the 12th of May, we're going to have a talk about amateur radio, in particular looking at the use of amateur satellites to broadcast or talk around the world, and also showing how amateur radio enthusiasts can actually talk direct to the International Space Station via one of the amateur satellites. So that will be coming along on Wednesday, the 12th of May. And then also in May, on Tuesday, the 18th, we've got a talk entitled Holes and Poles. And this is a talk by Carl Pimlet, and he'll be looking at some of the problems of actually getting fibre out to rural sites, and hence holes and poles, about all the things to do with digging trenches and putting poles in places and actually getting fibre as close to a premise as possible. And that's of particular note at the moment, because obviously with the government's desire to get everybody on fast, super fast broadband, there are obviously real practical difficulties in being able to install the infrastructure. So with that, I'd like to hand over to Keegan. Welcome, Keegan, to give his presentation this evening. Very much looking forward to this. It follows on from the talk on Tuesday from Vance, where Vance Briggs talked about things, Arduino and Raspberry Pi and their application to hobby electronics. And Keegan is going to take that forward into robots and how we can apply that sort of technology and also consumer electronics to robots. Keegan, over to you.
Oh, yes. My name's Keegan Neave, and yeah, I was about to give my YouTube intro. It's like the camera's rolling. I must do the usual spiel. No. Right, let's switch to the screen. Okay, so my name's Keegan Neave, and I'm first and foremost a hobbyist, and I love making things. So it's all sorts of stuff. Basically, it's every video I record, it always starts off with me completely fluffing and getting a bit flustered, and then I get into the flow of it, and it'll be fine, and that will happen again. So I've always been an avid maker. I'll go into a bit of my background as we go on, but who am I? I left myself notes, so that's a plus. I'm a massive nerd, if nothing else. And, you know, we've got to the point where saying that isn't a bad thing. You know, when I was growing up, oh, nerd, it was an insult. And yeah, no one wanted that. So I grew up watching Transformers, Back to the Future. In fact, I'm wearing a Back to the Future t-shirt with Doc Brown on it. And of course, short circuits. The relevance of that will be incredibly apparent soon. I went to Reading University to study cybernetics, and after the first term, well, pretty much first and second term, I discovered that the way they taught maths, for one thing, was basically beyond me. So I think it was my first ever lecture there was engineering mathematics, and I said, you know, how are we going to use Fourier transforms? How are we going to use imaginary numbers and things like that? All of these concepts they'd spoken about. And they said, you know, you'll find out in your third year. It's like, I really won't. You know, I learned very much by application. So just giving me the pure theory for 2 years was never going to work out. I ended up dropping out cybernetics and switching to computer science. And sadly, as part of that experience, I actually gave up on my lifelong dream of building robots for a living, which, yeah, funny how things work out, really. So I graduated with a computer science degree, ended up working at Microsoft for 6 years in Reading, working on developer support. So if you'd had a problem with Visual Studio, for example, or Team Foundation Server, I was one of the people who would have helped out with that. So yes, that was my job. But I was a I'm just seeing a few things about the video. I can yeah, it's not helping, I guess. Okay. Full screen image of Keegan. Okay, I can stop. Give me 1 second. I can stop trying to be fancy.
Keegan, I think it's fine for most people. There's just the odd one or two who are just having a few issues.
Cool. I will crack on and close chat so I don't get distracted in that case. Right. So yeah, worked at Microsoft for 6 years in developer support. But ultimately, I wanted to make my own problems rather than fix other people's, which is what I was doing at developer support. And you know, I learned an awful lot there, but I wanted to be a developer. So I left, joined a little startup who made me redundant, which wasn't ideal. But linking back to what Vance was saying the other day, I actually wrote a blog post saying I've been made redundant. You know, I've got all of these skills, and I'm a member of Reading Hackspace. rlab.org.uk, do look them up. And I wrote this blog post saying, you know, I'm luckily in the position where I was in Reading, surrounded by all these tech companies. I had the skills I did, I'd be able to get another job. So I thought I'm going to take this as kind of like a month off, as it were, to reskill, to learn some things and spend that time at the Hackspace. One of my old managers saw this at a company called the Satellite Applications Catapult, and he basically hired me on the spot, which was entertaining to say the least. I worked there for just over 7 years. And yeah, I quit, which is kind of A surprise for the next slide, but I've never done things in the correct order. But yeah, I was doing data visualization using the Unity games engine, and I'm still doing a little bit of that on the side. And yeah, so using satellite data to track illegal fishing, for example, using a massive video wall. I've done stuff in virtual reality, all sorts of things. But again, it didn't quite feel right, because I still wanted to build robots. That was still in the back of my mind. Then Pi Wars happened. I hope I put these in the right order. Oh yeah, I quit, basically. So I'll explain what Pi Wars is in a minute. But the whole thing of getting involved in this robotics competition made me realize that I can build robots, and I have been building robots on and off for a while. I've got a little Roomba that I hacked because it died, and I was able to control that using a Raspberry Pi and an Xbox controller, for example. Tried going part-time to spend more time on the robotics, but it just didn't work out, so I ended up quitting. The plan was to take time to reskill. If only there was a handy robotics competition to use as a focus. So one of the things was I wanted to use the robot operating system as well, and that is way beyond the remit of this talk. It's quite complex. I'll talk a little bit about it, but there's a lot more accomplished people who can tell you about that. Yeah, it's a wonderful open source project that is used everywhere. There's even aspects of the code base from the robot operating system in Ingenuity. It did its second flight today on Mars, so it's got everywhere. The other things I needed to do was massively improve my CAD skills. I was a novice, to say the least, making lots of rookie errors. And yeah, part of the plan for the company I ended up creating, Neve Engineering, was to redesign my Pi Wars robot, McFeegle Prime, and release that as open source. The plan was always to do that with the Pi Wars project, but ultimately, like I said, I was an incredible rookie when it came to CAD at the time, and I would have been embarrassed to release the CAD for that. So that's an upcoming project. And yeah, just to kind of get word out there, build YouTube and a Patreon base to try and get some funding in, and also find collaborative projects. So if someone wanted to build a variation of McFeegle Prime, for example, they could come to me, ask for help, and we'd build up that together. So yeah, there's a shameless plug, because I'm shameless. YouTube.com/NeveEng and Patreon.com/NeveEng. That's at the bottom of the screen in the footer as well. But yeah, if you want to learn more and outside of what I cover in this thing, just go to there and you'll be able to follow what I'm up to. So what is Pi Wars? First and foremost, it's non-destructive. So if you've seen Robot Wars, the likes in the old school days anyway, the likes of Hypnodisc and more modern versions, which is Tombstone in the US, they are brutal. You can put your blood, sweat, and tears into making a robot. It can go into the battle box, and within 5-15 seconds, it can literally just be on fire. I get too attached to the things I build, so I couldn't bring myself to do that. But Pi Wars being non-destructive, it was ideal for me. In fact, the closest you get to combat in Pi Wars is Pi Noon, where they put two robots in an arena with a stick with a pointed bit on the front, and a number of balloons on top, and whoever pops the opponent's balloons first wins. And that's literally the closest you get. So yeah, there's it's all based around the Raspberry Pi, hence the name Pi Wars. It's developed by the Cambridge Raspberry Jam, I think they call themselves. They're closely linked with the Pi Foundation out in Cambridge. And yeah, there's a mix of people who attend this. On the first day, it's kind of a kids and schools event. And on the second day, it's for the grown-ups. Yet to find one of the other competitors who doesn't share that opinion. We're all just big kids. We're just, our toys have got bigger. So yeah, that's Pi Wars. And here are some of the other competitors from this year. So this is Shetland Attack Pony. It's based around the Lorraine Underwood's. This is one of her robots, and it's basically they're avid climbers, and this is built inside one of their caving helmets. You get a lot of points for artistic merit as well as technical ability. So, you know, if you can put a theme around it, it's all the better. So that's Shetland Attack Pony. We've got International Rescue, which is actually based around Thunderbird 2. And it does actually have the pod that comes down, which all the wheels are in. You can see there that it's actually got a Nerf launcher on top to hit those barrels at the far end. These are the barrels we're talking about. They're used in the various challenges in this competition. We have Taurodime, and believe it or not, that robot is only just above the wheels. My mouse should work, yeah. Come on, mouse, there we go. So the robot is pretty much this bit down here, just the wheels and a bit above it, and all of the rest is an attachment just for one of the challenges. So the challenge was to sort these into two piles, green and red. They're toxic waste. So the theme for 2020 was disaster zone. So yeah, these are all based around the Raspberry Pi of various, and the competitors are of various levels. So Taurodime, I think, came second or third, and the winner was Spot Puppy. And this was an absolutely brilliant robot. It actually has 4 legs. It's a quadruped. It walks around. It's got computer vision with a camera in its nose, and it can actually go around, follow lines on the ground, and all sorts of stuff. It's a brilliant thing. And I'm rapidly running out of time. So what is my robot? It's ridiculous. It's called McFeagle Prime, and I had the idea when I was kind of scrabbling around for ideas for names. And if you're familiar with the Megabot team, they've made like a 19-foot tall, I think 2.5-ton robot with a pair of arms called Eagle Prime, because they're American, and you know it's all about the eagle on the shoulder and the stars and stripes all over it. And I was just playing around the idea. It's like, yeah, we've got the idea of what would happen if one of the Knack McFeagle from Terry Pratchett's Discworld ended up with their own mech. And so McFeagle Prime was kind of what came out of that. It was at about 3 in the morning when I was delirious with sleep deprivation. But yeah, like I said, back to Johnny 5. So the big inspiration for me was Short Circuit, and I wanted to develop my robot based around Johnny 5, and it was completely over the top. I'd never built anything on that scale before, and yeah, it just seemed like a ridiculous target to hit, so I went for it. I applied, and they agreed. They thought it was funny, which is kind of half the fight, and yeah, I got through. So these are the sketches I sent them. So a side shot of McFeagle Prime with the arms, the tracks, the weapons pod over the shoulder, specifically themed around the toolbox from Short Circuit 2. And the idea is any attachments needed for the various challenges would kind of come out of there. And of course, has to have combat mode. Again, one of the challenges needs a Nerf gun, basically. So I'd like the idea of him kind of crouching down, laser coming on, and going for it with the Nerf cannon. So the actual meat and potatoes of this talk is the kind of the consumer tech used to build what is a complex robot. And I'll explain some of the complexities when I do the demo in a short while. If you're familiar with remote radio controlled planes, or just, you know, servos in general, excuse me, the servos you can see on the left of the screen there, those are the 2 used in the robot. They're cheap. You can buy them in bulk off eBay. Oh, excuse me. The larger ones are actually in his shoulders and up to the elbow, and to move the head around. And the smaller ones are actually in the wrist, because you don't need as much strength for that length, at that distance even. The motors, he actually has 4 of the Pi-Bog motors. Again, these are just available from various Raspberry Pi shops, so you can just buy these online. About 15 quid each for these. But if you have 4 of them, you can actually move a robot that weighs in at about 4.5 kilograms. And McFeagle Prime came in a little bit heavier than expected, so I ended up needing all 4 of them. So that's kind of the actuators. You've just got the servos and the motors. And again, there's plenty of examples on how you can control these using Raspberry Pi and Arduinos. And in my case, I used the Raspberry Pi, Teensy, and the Redboard. So the Stereo Pi, you can see on the left there, it looks, I thought I brought it over here, but it doesn't look like your standard Raspberry Pi because it's based on the compute module. And these are essentially a little, it's like a RAM chip basically that slots into a carrier board. And it's got all of the processor processing the memory of a standard Raspberry Pi. And you can design your own hardware around it. So a company called Stereo Pi, they actually made this wonderful board called the Stereo Pi, which gives you access to a pair of cameras. This allows you to do stereoscopic vision, from which you can actually get you can create depth maps and things like that. So the eyes on the robot are actually dual cameras, so it's not just for show. So yeah, that's kind of the brain, literally the brain of the robot in this case. And that does all of the kind of the higher functions. Now that is attached to a Redboard Plus by Neil Lambeth of Red Robotics. He's actually a Pi Wars competitor from previous years, and he designed this Redboard, which has everything he needed for his robot. So it's got a pair of 6-amp motor controllers on there, motor drivers. It's got up to 12 servos, I think it was. Various other things like an analog to digital converter, so you can measure voltages, and a few other things that I'm not even using, to be honest. But pretty much everything you'd need if you wanted to build a robot based on a Raspberry Pi is in the Redboard. And in fact, I've got one here that I forgot about. I do have props. So yeah, you can just buy these, and not sponsored or anything like that. It is just a brilliant bit of kit. But you can just buy one of these and then literally press it onto the top of a Raspberry Pi. And that's it. You just give it power and you're good to go. There's loads of great examples from the code base as to how to control a robot. Other people like Tom Owen of Approximate Engineering, also another Pi Wars competitor. He's rewritten the libraries and put a lot more examples out there as well. And it's just a kind of a great kind of easy mode way of getting into this. Because it can be incredibly daunting if you've not really done anything like this before. And it was for me, I'm not going to lie. It's just it can be quite daunting because there's a lot going on. But with all these great examples and tutorials, yeah, it's a great place to start. And finally, we have a Teensy, and that's one of these. It's kind of an Arduino clone. It's got a different processor, and this one runs at 600 megahertz, which is frankly ridiculous, but it's a fantastic bit of kit because each of most of these pins can actually act as voltage sensors. So you can detect, not that I've implemented it yet, but you can use it to detect the resistance values essentially from the different joints in the robot. So you'll actually be able to tell where the arms are, as well as where you've told them to be, which again, I'll speak to that in a few minutes. But that is essentially the guts of the robot. There's a battery in there as well, which I threw together out of parts I scavenged from laptops. But you can just buy those off the shelf and plug them in. It just runs at 12 volts. So everything is off the shelf. Now, the robot I'm about to show you is very custom, like the one I actually built for Pi Wars, but another example is this. This is the Robotics Turtlebot 3. This is kind of an industry standard learning tool for the robot operating system, also based around the Raspberry Pi. So it's just nicely packaged and an easy way in. But yeah, obviously it's not quite as custom. So for Pi Wars, it wasn't what we needed. So next slide. There we go. This is McFeagle Prime. On the left is an earlier photo looking a bit worse for wear without his tracks. and all of his wiring showing. And on the right is the controller I actually made as well. So it's both of them run on a Raspberry Pi, and you can't see the screen. Yep, sorry, I'd forgotten to put that back on. Yeah, so that's the controller I made. And yeah, they're both based around the Raspberry Pi. They use the robot operating system to kind of communicate between them over Wi-Fi, essentially. You've got 2 3-axis joysticks on there, so as well as X and Y, like you'd expect from a gamepad, you can also rotate to give an extra axis just for that extra bit of control. And yeah, I think I'll start skipping ahead. Oh yeah, these are a few things I'm going to do for a future version. Is add in some more sensors. So there's inertial measurement units. So you can actually have an accelerometer, gyroscope, and things like that. So you can see where the robot's oriented, and there'll be one in the base and one in his head, so you can see the difference. So you can tell where he's looking, as well as where the robot's pointing, and that'll be useful for generating 3D point clouds. There's the stereo cameras. They're actually already running. I can show you those at the end, and servo feedbacks. At the minute, I can tell the robot to move his arms in certain ways, but for all I know, the arm's fallen off and it's not actually doing what I've asked. That has happened. He once actually ripped his own arm off in protest, I think. But yeah, and the URDF, the Universal Robot Definition File, that's a robot operating system specific thing. But yeah, it's a configuration file which represents the robot, so that I can start using other tools of the robot operating system, like the Gazebo, which is a simulation system, and Move It, which is a module that allows you to have control complex robotic arms rather than having to do the kinematics yourself, which is a nightmare. As I've said earlier, I'm not great with maths. So yeah, that's a future thing. Follow me on YouTube to see how I get on. Right. So this is a live view. This is McFeagle Prime. So I've got a couple of cameras set up on my desk, and yeah, he's actually running as we speak. So yes, I have got that on the screen. Cool. I just need to start running some code on the controller. And oh, it's running. It doesn't report back anymore, does it? So what you can see here is the robot itself, and I have the controller here just out of frame. And essentially there's a couple of different modes. So, ooh, come on. There we go. Like I say, there's a slight bug that occasionally he rips his own arm off, but thankfully I caught it before it happened. So I think one of the reasons why I said this is a complex robot is specifically because of the arms. And if you're familiar with actuators and arms and things like that, they have something called degrees of freedom. Now, in the case of humans, we have our arms, up to the hand at least, are 7 degrees of freedom. So we've got one which is, one joint at the shoulder, forwards and backwards. You can go in and out and flap. I call that the flappy axis on the robot because I don't know the anatomy. So it's a flappy axis, it's just what it's called. And obviously your upper arm can rotate as well. Now you get down to the elbow, you've got another joint there. You can also rotate at the wrist. The wrist can go forwards and backwards, but also slightly side to side. And those are the 7 degrees of freedom. And that's what I've replicated on the robot. Because not only was this for Pi Wars, the idea was that this would be for ongoing learning, development, and things like that. So with the stereo cameras, and I've actually had some success with this already using a Google Cardboard headset, but with the stereo cameras, you can actually get a 3D view in close to real time, at which point you can teleoperate the robot and control it directly. I've actually had it driving around upstairs in the house, and there was one weird bit when I turned around, caught my reflection in the mirrors we've got in the bedroom, And there was just this weird moment of disconnection where I was looking at my reflection, but I was a robot, and it was, yeah, that was a weird one. But yeah, the idea is with the complexity of these arms for teleoperation research ongoing, it's just going to be fun to play with, if nothing else. So with the controller, we can see if you pull it joystick backwards and forwards, you can just see that in the bottom of the screen. That's the shoulder moving. So that's 1 degree of freedom, moving backwards and forwards. We've got the flappy axis. And yeah, it can rotate in and out as well. Now, these joysticks also have a button on the top, which is essentially a modifier. I'm using it as a shift key. So if you press and hold that button and push it forwards and backwards, you can get control over the wrist as well. Now, I'm going to use the right arm for this because I know his hand's a lot better. But one of the challenges of Pi Wars, as I've said, is to sort these barrels. And the only challenge of 11 that would need the arms is this. Now, it's ridiculously complicated having an extra 20 odd servos purely for one thing, but again, completely over the top, and it was just for a laugh. Well, it was to start with anyway, and then I quit my job. But so yeah, what you're able to do is, you know, he can put his hand out, can switch mode, can open his hand, and there we go. So fairly quickly, you know, though albeit manually at the minute, the arms can actually be controlled to get complex maneuvers that, yeah, you know, similar to that of a human. And yeah, so you can do some quite complex procedures with that. Now, this is the version 1 of the robot. I've already got a long list of lessons learned. So, for example, at the minute, the is a bit wobbly in various places, and that's all going to be tuned out in future versions. But yeah, this is a learning experience, and yeah, it has been a learning experience. Now, one of the other things I was going to mention was the eyes. So for one thing, as well as controlling the arms with the joysticks, you've got the 2 tracks there that you can use to move him around. And I've learned my lesson and put him up on blocks, basically, because, yeah, don't want him falling off. If nothing else, with as much as he weighs, he'll probably go through the floor. So you've got the control over the tracks there to actually move the robot around. And not only that, but you actually have control over the head as well. So you can actually look around your environment and get a better viewpoint as needed. Now, these cameras, the 2 cameras, can actually show. They're not the standard Raspberry Pi cameras. These are WaveShare ultra wide, and I think they're 170 degrees field of view. So you actually get quite a broad view. So it takes a while to get used to seeing through them because it's a little bit wider than the human vision. But yeah, and again, there's the red board in his head with the stereo Pi board underneath. And yeah, I will just bring the cameras online and show you that quickly. And then I think we'll go to Q&A because, oh, sorry. Right, if we switch to screen sharing. So actually, no, I added one, didn't I? Yeah, so what we've got there is the robot, a view of the desk again, and my screen. Oh, so what you can see there is, I don't know how well this is going to come across, but yeah, there's about a quarter of a second lag between me clicking my fingers and the robot showing the results in the browser. So, and at the minute that's top down. So you've got, it's a bit weird to look at it because you've got one at the top of the screen and the other one below. From a programming perspective, it's just more efficient to split them that way. Though, you know, we'd be used to seeing them left and right. But yeah, that's why there's this top bottom orientation for this. But yeah, and again, you know, you've got, with control over the camera, with his head even, you can actually look around and get your bearings that way. I know that this has been quite a whistle-stop tour of what's possible. And again, because it's such a broad field, it's difficult to say this is how you build it, because that would be probably a series of videos. In fact, it has been a series of videos in its own regard. So if you do want more information, you can look me up on Twitter and all the rest of it, and do feel free to ask questions after this. I encourage people to get in touch, because it's always good to nerd out with other people. Let's quickly go back to the slides to see if there's anything I've missed. No, Q&A, excellent. So yeah, if you want to look me up, I've managed to get Neve Eng on pretty much all of the platforms of choice, on GitHub, LinkedIn, Instagram, and all the rest. So if you do want to look me up and ask me any questions afterwards, feel free to do so. But yeah, other than that, I think we'll probably go to Q&A.
Okay, thank you very much indeed, Keegan, for your presentation. I'm afraid I missed some of it because I was busy answering questions and so on. So,
well, thankfully it's been recorded, so you'll be able to watch it in about a week's time after it's been processed on the
yeah, and then I'll find
website.
out what I missed. Yes, well, I apologise for missing out on some of it, but you know, I used to do hospital radio, and when you're DJing, you find it's very difficult. You never hear the music because you're so busy thinking about what's the next piece of music, what you're going to say, have you got to play in jingles, and so on. You rarely ever hear the music. So,
yes, oh yeah, it's a nightmare. It really is. Like I said, when you're doing live streams, you can barely know what's going on at the best of times. So I'm speaking purely for myself.
Yes, yeah. If we, I was needed an extra brain. Okay, I'll feed you some of the questions that we've had. Just in general, a couple of things have come up that any questions that aren't answered, or let's do it this way. All the questions we fed to Keegan, and if he's already answered them, he may just put brief notes, but any unanswered questions, and Keegan's kindly agreed to answer them, and they'll then be put on the homepage for IET Bucks local network, so that you can see answers, and perhaps they may give a bit more information as well, because it's always easier when you're writing something down than when you're trying to think about giving an answer on the hoof, so to speak.
Yes, yeah.
And just to reiterate, I had several questions about the CPD certificate. The CPD certificate is now posted in the blog section of IET Bucks local network homepage. Again, I put this out on the chat line, but the best thing to do is just Google IET Bucks events, and that gets you far faster to our page than going through the IET's own search engine. And when you go there, you'll find there's a blog, and there's posted CPD for today. It's worth 2 hours. And you'll also find, if you were on the webinar on Tuesday with Vance Briggs, you'll also find the CPD certificate for that. And that was also for 2 hours. Okay, let's have a look at some of the questions. Grissom Zeng said he very much enjoying the talk, and asked the question. He only knows about Raspberry Pi Pico. His question to you is, may I ask if the Stereo Pi, Redboard, and Teensy are multi-compatible in hardware-driven layers under the same Linux OS?
Yeah, yes. So the way it's structured is there's the Stereo Pi. You can think of that as the actual hardware, the Raspberry Pi itself, and that's what everything is running on. It just gives you access to 2 cameras rather than 1. That's essentially what the Stereo Pi board does. And all your code runs on there as it would with a normal Raspberry Pi. Now with the With the Redboard, it does have an abstraction layer. So you have the Pi GPIO daemon, or pig powered, as you have to type in to get it running. I was just thinking oink, oink as I get that running, but then again, I'm a child. So it runs this daemon, which is an abstraction layer between the operating system and the hardware. So you can have multiple programs all talking to the same things on the Redboard. So I've got, for example, I've got a motor node which runs the motors. I've also got a head node which moves the head around, and an arm node. These are all talking through the Redboard to the various components, but from separate processes. So yeah, they are all abstracted apart from each other. And I have seen some Neil Lambeth again, who created the Redboard. And yeah, I've got all the props because I do have all the toys. He's got a Pico, a Raspberry Pi Pico, which if you've not seen it, it's a microcontroller from the Raspberry Pi Foundation. He's actually got the Redboard Plus hooked up to the Pico. So he's been doing some playing around with that as well. But yeah, they're available. As long as they're plugged into a Raspberry Pi, you can use the Python examples, basically. So yeah, long answer to a short-ish question.
Well, thank you very much indeed, Keegan. A couple of people asked this question, but the first one came from Simon Waller. You mentioned the compute module. I'm not sure whether Simon actually means computer module.
No, it is a compute module. So yeah, it's right on that one.
How does that attach to and communicate with the Stereo Pi, please?
Hopefully I can show you if I've got it here. I do, yes. Cool. So the Russell. Oh yeah. So this is the version 1 Raspberry Pi compute module. So as you can see, it looks like a stick of RAM because it's using the same form factor. It's DDR2 or something like that, I think. But it has the processor you can see there. That's the same from the Raspberry Pi 3 Plus, except it doesn't have the Wi-Fi on board, which is kind of annoying. There's also the compute module 4, which is based on the Raspberry Pi 4, as you'd imagine. That's got Bluetooth and Wi-Fi and all sorts on there, and up to 8 gig of RAM, which is ridiculous and brilliant. I've actually got one of those running in the Turtlebot over there. But yeah, as you can see, it just has these contact strips down the bottom. I don't know if that's the proper name for it. But on the underside of the Stereo Pi carrier board, it literally just pings in like a stick of RAM. You give it power and then it just runs. So.
Okay, thank you for that answer. Several people are asking, how do you build and manufacture the hardware for the arms and hands, please?
Right. Over here, I've got a stack of IKEA LAC coffee tables, which actually contain my 3D printer. So you can just see in there my Prusa Mark III. And I've got another one below it, which is a clone of the same. So I've got 2 printers. I used Fusion 360, which is free for hobbyists. And like I said, made lots of design errors in the early days, but bit by bit, basically 3D printed the whole thing. So if you look a bit closer, you can actually see the layer lines from the 3D printing. And again, you know, you can buy these 3D printers for a couple of £100, even cheaper now. And this is consumer grade, you know, as far as I'm concerned. It's not like the old days where you'd have to spend, you know, 50 grand on a big beast that you've got to knock the wall of your building out to install. You can buy these on Amazon. It's delivered in a couple of days, and you can spend a weekend building them and then print things out. Like, again, I've got another one here, 3D printed case for a Raspberry Pi, but it's got VESA mounts on the back, so you can mount it on the back of a monitor, for example. And, you know, you can just do these sorts of things now. So, yeah, 3D printing.
Yeah. Okay. Well, thank you for that. I mean, I was just going to follow on that. I mean, in Vance's talk, he mentioned about using Fusion 360, sorry, which I've recently just tried with, and it does seem a very nice, intuitive piece of free CAD software. all you have to do is sign up to it, but swear blind you're using it for educational purposes. But it then opens effectively all your designs are open to anybody else. And there's a whole world of information about 3D printing in the sense of STL files and so on is it Thingiverse? Is that correct? Yeah. So if anybody wants to sort of start or maybe find designs for, let's say, the Raspberry Pi case, there's lots of stuff out on Thingiverse. Just a matter of interest on the 3D printers you've got, you say they've only cost a couple of £100. Now, how effective have you found them? Because I've both used a machine that cost about £700. I'm not paying for these, fortunately, which didn't work. It worked all right, but not brilliantly. But somebody I work with has recently acquired a MakerBot machine, which are much more often the £2,000 thing.
Yeah.
You certainly notice the quality in the £2,000. I appreciate it's outside the range of most amateurs. I just wonder how your £200 machines worked, how well they worked.
So I bought, the second printer I mentioned, the clone, that was actually from about 5 years ago. And that was about 280 quid, I think, back then. And if this was a different forum, I might be willing to swear, but I won't. It wasn't a pleasant experience. Now, in those 5 years, things have come a long way. So the likes of the ANET A8, the Creality Ender series of printers and things like that, they are in this 200 to 300 pound range, and I've heard nothing but good things about them. And again, because the likes of the Prusa, which I basically worked my kit printer to death, and because of that, I bought cheap, I ran it into the ground, and therefore felt it was worth investing in something a bit more. So I ended up using my Prusa to print the parts to make the old one work. And it's just that's what, the replicator, the clues in the name. So the old parts, it's all the same components, but just in the more modern frame mounts and the way that it all links together. So just the fact that you've got the newer designs there, the same hardware will work so much better. So the cheaper ones, you do have to put more time and effort into just to get them going. And the likes of the Prusa and the one you mentioned, they're a bit more turnkey.
MakerBot,
yeah. So it's if you've got the time to put into the cheaper ones, you can get a fantastic bit of kit out of them.
I believe part of the key to it, and just before we move on to other questions, is making sure you buy decent quality PLA filament, if you're using PLA or any other filament. There's a great temptation. I'm talking to somebody who's used a lot of this to sort of buy cheap and cheerful, and it's one of those things where if the medium you're trying to extrude is cheap and cheerful, that's where it causes problems, where you get breakages and it strings out, and it is worth paying the money. And 900 grams of high quality PLA, will cost about £60, which is quite a lot. But my limited experience of this, that also probably repays it rather than trying to buy something that's
I used to get kilogram reels for about 22 quid, and that's 3dfillerprint.com. Again, not affiliated, they've just always sold good stuff to me. So
but you found that works all right with 20
brilliant. Yeah I printed like literally 100 visors this time last year, and they were all rock solid. So
okay, all right, well, enough of my questions. A couple of people have asked the question, are the cameras on your robots just for vision, or are you using them for functionality within the robot itself?
So if I'm understanding that right, so there's a few different things you can do with cameras and robotics. So for one thing, you can literally just view a live stream and get your bearings and control it manually that way. I am going to be doing computer vision. I'm very early days on that, I'll admit. I've already started playing around creating disparity maps, so you can actually use the stream from the two cameras to get the difference in pixels from which you can get depth and things like that. So I'll be using it within the robot operating system to actually generate a point cloud so the robot knows where everything is in 3D space. The other thing you can use cameras for is visual odometry. And basically, if the camera's fixed, or if you've got various extra sensors so it knows where it's looking, as the camera moves around, you can run an analysis on the video stream to detect how the robot is moving. At which point you can, if you've told the robot to go forward by a meter, you can use the odometry from the camera to confirm that you have actually gone a meter. Whereas, say, if you're running on carpet as opposed to a hard floor, it will go a lot slower. So, it can go, oh, well, I've asked it to go a meter, but it's only gone half. So it can actually go, right, well, I need to go that bit further. So you can use the extra functionality there. I've got plans to do that, but at the minute, it's literally just pretty much a live stream from the cameras.
Okay, I think that. I think, as far as I can, I think your answer did meet the intention behind the question on that. Right, a question from Nick Smy. Are Pi War robots essentially manually controlled by a human for the challenges, or are they automated?
So one thing I didn't cover was the different tiers within Pi Wars. So you have essentially beginners, intermediate, and advanced. And you've got this in both the schools competition and the everyone else competition on the different days. For the beginners and intermediate, you can control it manually, and that's perfectly fine. And within your group, you will be measured against those kind of values, and you'll have a beginner's winner, an intermediate winner, and an advanced winner. If you're an advanced, you have to attempt to do everything autonomously. For the first year for 2020 for Pi Wars, I was in the intermediate category, so I could have got away with doing lots of manual control. You can opt to do it autonomously as well if you kind of get ahead of yourself, which is fair enough. But yeah, you can do either, just so that as many people can get involved as possible. So because it's back to being quite daunting. After Pi Wars 2020, which was virtual event because pandemic, I was then bumped up to the advanced category, which was kind of it was gratifying because I'd obviously come a lot further than I thought, but it's really daunting because I've seen the autonomous capabilities of some of the other robots. Torodyne, for example, the one where it was the rope. The robot was this bit, and then it had the attachment on top. That's one of Mark Mellor's. It's him and Rob's robot, and that is all autonomous, and it's phenomenal to see it actually moving around under its own steam. So yeah, it can be either. I'm aiming for autonomous, but obviously with the controls, you've got the manual backup in case the autonomy doesn't work.
Okay, thank you for that. That is interesting because, I mean, it's an interesting question as well, because Robot Wars is slightly misnamed because it's people using, in effect, model airplanes to controllers. I mean, you can see them on screen, effectively just controlling these vast lumps of metal charging around. So there's very little automation. I think in the last series that was on, the one fronted by Dara Breen, I think there was a unit which had some sort of little satellite units, which you got the impression they might have been semi-autonomous, but I suspect there was actually a second controller. But it's always a bit disappointing because to me, robots should have a autonomy. Because
I mean, I'm not in that community, as it were, as an active participant, but this is something a somewhat heated discussion which comes up from time to time.
Yeah, I can imagine. I'm just giving you my personal view that robots should have some degree of not necessarily ability to think, but some sort of degree of autonomy, rather than somebody just going, "Yeah, I'll steer around that."
So some of them do, like Chomp, which if you've seen the latest season of BattleBots from the US, it's actually got 6 legs and it's at like 500 kilograms. It weighs almost as much as my old Mini. It actually has a turret on top, which does have a level of autonomy built into it. So yeah, there are some that have small amounts of autonomy, but the complexity of purely autonomous is slightly terrifying if it goes off whack.
I had a colleague at work who designed a walking robot, which took part in one of the very early series. and it's successful, but it did have a level of autonomy to get it to walk, and then he was controlling where it steered. But the walking bit was a 6-legged robot, so he designed it around sort of typical insect movement. It worked very successfully. But it had that sort of I'll do the walking, you tell me where to point sort of.
Yeah, and that
started being a proper robot as far as I was concerned.
Yeah, inverse kinematics that's referring to. You've said go forward this amount, and there's a program which interprets what you've asked it to do, and the arms and the legs in this case move in a certain way. That's something like, I'm adding to the robot arms at some point.
Yeah. So. Yeah, a bit like some modern planes, where
yes,
I'll tell you where I want to go, and the plane works out, checks it all out of the sky. Okay, a couple of questions about arms, and I'll put them together. They come from David and Jerry. David, and also another gentleman called Jerry Stone. Do you have position feedback in the arm to generate a feedback loop? How's that done? And how do you use an actuator to control the arm?
Right, so I'm going to answer these the other way around. So
okay, fine.
Right now, I don't have any feedback coming from the servos. Now, I do have a short video on my YouTube channel, shameless plug, of how I hacked one of the servos to give that feedback, because all the servo is essentially is a motor with a potentiometer. So as the motor moves, it turns the potentiometer at the same time, and within the servo itself, it knows that the horn, the output of the servo, is basically that's pointing in a certain direction. What you're able to do is if you take them apart and solder a wire to the wiper, they call it, the potentiometer, and then hook it into something like a Teensy or an Arduino, you're actually able to get the feedback that the servo is using itself to say, okay, if it's between 0 and 3 volts, for example, you can see if it's at one angle or the other. So that's what I'm working towards adding, but I've got like 20 odd servos in the arm, so that's a future project at the minute. But as well as giving feedback on where the arms are, it allows it to be back drivable. So what you can then do is you can basically grab the arm and say, right, record this movement. And because you're telling it to go between certain movements, you can get the feedback from the motors, and then the robot can redo those actions. So it's a handy way of, rather than having to figure out how to program it to do all of this, you can just have it record it and use it as a macro. So, but the other thing is, if you've got the feedback from the arms and you say, right, lift up this cup, but it turns out to be a lot heavier than expected, and it's actually down here, you can detect that and prevent the motors from burning out, because you're going, okay, it can't get that high up, bring it back a little until it's actually where you've told it to be is more in line with where it actually is. Because I've had servos burn out and the magic smoke is released. So yeah, excellent question. It's definitely something I'm looking towards doing.
Here's a slightly different question, just based, I think it's just come in, and it's obviously based on a previous answer about the use of vision and functionality. This is from Grizom Zeng. Do you think it would be feasible to deploy cloud AI service? So, and he mentions a particular one, i.e. human face recognition. Could you deploy that in your robotics?
Yes.
Yeah.
So yeah, short answer. But again, back to the robot operating system. It's been around since 2007, originally produced by Willow Labs for their robot, the PR2, I think it was called. People have done modules left, right, and center for this. So I've mentioned the Move It, which is for the inverse kinematics for complex arms. Excuse me. But there's also a lot of code out there for the OpenCV, which is the Open Computer Vision Project. So if you can do it in OpenCV, you can, which has lots of stuff for face detection, for object detection and things like that. You can actually run that on the robot quite happily. On top of that, you can get things like the Movius, I think it's called, the Intel Compute Stick 2. And this is actually a USB stick that you can plug into any computer, and it actually gives you a neural coprocessor. So you can actually load machine learning models onto it, so that rather than having to do all the complex computation on the CPU of the robot, which can be quite limited for a Raspberry Pi, you can offload it to that and it'll give you the answer much quicker. You can also hook it up to any other computer, because the robot operating system is distributed by design. So you can have a desktop PC in the same room that the computer is running in, or even hook it into like Azure or AWS or your platform of choice. And as long as you're happy with the latency that's involved, you can use any of their facilities to actually integrate back to the robot.
Okay. A couple of people have asked, what language do you program your computers in?
So primarily for me, with the robot operating system, it's Python, purely because there are the most tutorials out there. So it gives you the best chance of being able to figure out how to do something. If you're doing the more complex things, you can use C++ too. Well, C++ as well, not C++2, you know, that's probably an old version by now. But yeah, you can, but the thing with the robot operating system is you can use whatever you want. So there's JavaScript, Go, Perl, Basic, even all sorts of stuff. But on top of that, you can just use Python. So I talk a lot about using the robot operating system. You don't have to use that. It's just what I'm choosing to use. But yeah, Python is a great way of getting into it, because there are so many examples out there. So typically, if you get one of the hats, not only the Red Robotics one, but the servo hat or the motor controller hat from Adafruit, for example, who Vance mentioned on Tuesday, they've got great examples in Python as to how to actually use these boards. So it's a great, easy route into programming these things.
Okay, thank you very much indeed. A slightly unusual question. There's,
Oh, I like those ones.
Oh well, let's see. I find it slightly unusual. This comes from Ian Downey. Have you managed to get any free software working that can convert photographs to a file for 2D printing?
Okay, so I know that there's, and Vance can probably back me up on this one. So there's a lot of things at Reading Hackspace when you go upstairs into the kind of the lobby and the kitchen bit, where people have taken an image and they've either laser etched it into wood, or they've extruded it. And I can see Vance is just unmuted, so he's probably going to help out here. But it's similar to what I've done in the past with satellite imagery. So I don't know the software, but I know that you can, and hopefully Vance will assist on this one.
Yeah, well, unfortunately, I don't have the name of the software, but I do know it's possible, and I think one of the designers that works or comes down to the Hackspace, so I think he uses an app on his phone actually, and you take multiple images around the edge of the object, and you can build a 3D object. The slight difficulty is that's fine for sort of art type projects where the dimensions aren't necessarily critical. But if you're trying to do something from an engineering perspective, the tolerances on the 3D model are really not suitable, if that makes sense.
Yeah. So the process of using multiple images to generate a 3D model is actually something called photogrammetry. And that's used extensive with drones, for example. You can create big 3D things. I think so. Keywords that would be good for Ian, Ian to search for would be generating a depth map from an image. So from satellite images, for example, you have black, which is the lowest value, and white, which is the highest value. And depending on the grayscale value, it actually maps to an altitude. So yeah, there is software out there. I've seen websites where you can put an image in and it will have a stab at generating extruding into 3D, but yeah, for the life of me, I'm sorry to say I can't remember. the names
Ian
of
was actually asking about converting to 2D, which isn't quite the same problem. I think he's looking for free software. I mean, I do regularly use some software, again, for somebody I work for, which is called 2D. Yeah, it's certainly not free. It's just sort of like a poor man's version of AutoCAD. But there is a feature called contour mapping, and you can feed in a photograph, particularly one which is been taken with a lot of definition, or sorry, almost overexposed in the days of film, yes, a silver nitrate film. So you're really only getting the sort of almost like a silhouette, and that will, you can say, set contours. And again, a bit like you were just describing with the height thing, you can sort of adjust the parameters. And that is actually quite effective. I've used it because somebody asked me to produce a map of the world, and what we did was found something online, was just a sort of typical picture of here's what the world looks like on a 2D map, and it was coloured and had lots of other things. We fed it into the 2D software as a contour, and it picked up the outlines of the coast. It was a bit fuzzy, but you could adjust that relatively easy. And then we fed it into a laser cutter, which then cut out the shapes, and they were quite happy with the results, and frankly so was I, because it worked better than I thought. But it is available. Whether you can get it on free software, I don't know, because it's a sort of a bit possible, but I think you might have to search around, Ian, to find out about that. But it can be done. The thing is, it's called contour mapping or some similar name, and I suspect it's the same in 3D from what you're saying. If you're trying to do 3D mapping, I expect contour mapping sounds even more relevant there, doesn't it?
Yeah.
Okay, I'm just looking through quickly because I'm conscious of time is ticking on now. I'm just looking through if there's any burning questions we haven't answered. I think you've answered all the questions where the same question's been asked by a number of people, and you will get a download of this. So that if anything you can see that you haven't picked up on or can answer with a bit more leisure, just checking so that nobody misses out on anything special here. And no, I think we've answered all the burning questions. And thank you for that. And Vance, thank you for coming in. I mean, certainly this is shows the use of some of the technology you demonstrated on Tuesday and talked about on Tuesday, about how it's being put into actually what is quite a complex project, but it is all just relatively easily available items, and you're now able to put them into doing sort of quite complex tasks. And obviously there's more to go if you're looking towards things like AI to help you guide the robot, give them sort of a fair degree of autonomy. Be interesting to know what NASA is using for their little drone, because we know from the news reports that's entirely autonomous, and just sheer engineering common sense tells you the radio time. You can't have somebody sit there at the joystick sort of hoping in however long it takes for the signal. I can't remember what it is. It's about 5-6 minutes to Mars. I can see a mountain coming up. I'll haul back on the joystick, and by the time it's received it's sort of hit the wall. It'd be interesting to know exactly how they're doing, how much AI and sort of pattern recognition they're using to make sure it doesn't plow into things. But I suspect that's something we'll learn as they get more confident. Obviously, you're quite pleased with the first flight. Was it on Tuesday they gave the first flight?
Yes, and I think they did a second one today. So the first one they just went up and came back down. Today they actually went up and translated horizontally and then came back down. So
yeah, it's been interesting to know exactly what, apart from the deep things, but it's sort of almost like at a high level, what are they saying to it? They're saying, right, when you're ready, I want you to go up, look out for what you're doing, sort of proceed in, so far this thing, and then land again. It'd be interesting.
It's back to the kinematics. It is just saying, go to this altitude, move across by this amount, similar to what you can do with mission planning on a drone. And then come back down. It's just, it's a bit more difficult for them to go out there and pick it back up if it lands wrong.
Yeah. So there's obviously got to be looking out for hazards and other things. So, okay. Well, Keegan, thank you very much, Steve, for your talk.
Happy to.
it was interesting, and also following up on the questions which helped bring out various factors of the robotics. Vance, is there anything else you'd like to add? No, I'll shake my head. Okay. All right. Thank you, both of you, for joining in this evening, particularly you, Keegan, for your presentation, particularly the live video, which you acting as your own cameraman, director, sound man, or whatever. And that was really nice to see the demonstrations there. So with that, that's the end of tonight's webinar. Thank you for being in the audience. Just to say once again, if you wish to get a CPD certificate for this evening, there is one already set up. All you have to do is write your name into a box which says your name here. It is an editable PDF. That's available at the IET Bucks homepage. I've also put on the chat line, if you go back up there, you'll see I'll put the URL direct to that. Alternatively, you can just go to the IET site and you can pull out a blank CPD certificate. If you do that, it is 2 hours CPD time on tonight's talk. The recording will be posted, I hope, in just over a week's time. Same with the Q&A. I can't give a guarantee of date because it is variable. How long it takes to get the recording processed. I'm not sure what they do, but it does just seem to take a little while to get it processed. Thank you very much indeed, and good night, and I look forward to seeing you at another webinar. Our next webinar is on the 12th of May, when we'll be looking at amateur radio and the use of amateur communication satellites. Thank you. I'll stop the recording.